Yeah, okay. And so before we start talking about the market channels, we'll have a quick review of what we covered last week. So last week we discussed about this analysis framework. If you remember, it has three main parts, which is what, why, and how. And so that's the diagram we would see quite a bit over the course of the module and in a few different lectures. And so what is about the data? And so I think that's the second lecture. We talked about this, and we talked about many different data types, data set types, and then finally attribute types. So the reason is we need to know the types of data, then we can select the visualization suitable for the type of data. And for example, if you know the data is about locations, then map is probably the best way to show it. Okay, and then what we covered the last week is about the why part, is in terms of the type of analysis task user want to do. And so it's about task abstraction. Again, so whether an evaluation is effective or not largely depends on, does it meet the requirement of task? So for example, if the task is to get in an overview of the entire data set, then the visualization design for that will be very different compared to the task where you want to examine individual data items in your data collections. And then there are many different types of tasks. That's why we need to understand that. Okay, and then finally is the how part. The how part is actually designing or creating the visualization. So once you understand the type of data you want to show and the type of task you need to support, then you have to, based on these two information or requirements, and to decide the design of visualization to make sure as effective as possible. So we already said a few times, and the only criteria to measure how good a visualization is how effective it is in terms of how accurate people can find answers or how fast people can find answers. It's not about, say, how attractive the visualization is or how beautiful, whether it's 3D or has lots of colors. It has nothing to do with any of those. Okay, and then related to the how part, there's this concept or term called idiom, which is very important. And so it's like the design guidelines, which tells you if you know the what and why and how do you design the visualization. Again, so this is like a guideline, so it's not strict rules, but it's based on previous experience and research and studies. So these are usually work, at least give you a good starting point. Then you can further refine it based on your specific data and task. Okay, and then so the idioms is not just about visual encoding, which in terms of design of the visualization, but also about interaction as well. So there's different interactions you can do, simple ones, like a mouse over or filtering or even. So these are the ones that have its own idioms as well. And okay, so I'm not going to go through this again, but this is the what part and talk about different data types, data set types, and attribute types. So attribute is one of the the data type. Okay, maybe spend slightly more time and to talk about this. And so this is what kind of the majority of the time we spent last week, talk about the why, and it talks about the actions and then targets. So the actions is the actions user need to do, and the targets is the things user want to find from the data set. And yeah, I just want to repeat again. So all the terms used here has its very specific meanings defined in the context of this analysis framework. And later on, when you do your coursework, you need to apply this framework to a specific data set and then an analysis task. And when you do that, you cannot use these as a more kind of common English words. For example, you can't say lookup as a normal English word, but it very specifically means a type of search where the target is known and the location is also known. That's a very specific type of search. Okay, and I think the good thing is most of these terms used in this here, their meaning is very similar to their common English meanings. But for example, consume, produce, or discover, these are all very similar to the usual English words how would you use in writing. But for example, the different type of searches are very specific ones. I think that's the one people usually forgot. Okay, and back to the actually why framework. So this part is the type of the things or the actions user do, and this, the right-hand side, is different things user need to find. And so in terms of analyze, okay, and the second thing is say the actions goes through three hierarchies. In the sense, analyze is the top one, and all the analyze would have some search inside, and for each search is one type of these queries. Okay, so for example, you might do a lookup, and in the lookup, you either identify something, compare something, or do summarize. So that's, and then the lookup could be part of discovery or could be part of the annotate. Yeah. Okay, and then analyze, the top level, you first have consume and produce. And consume is the part where you don't create new data, whereas produce, you're producing some new data. Again, so this is important to see for the produce, when you're creating new data, the data is not, say, arbitrarily and creating some new data points, or just by including a new data set into the analysis. That's not called produce. And rather it's, say, annotate, where you write down what you discovered, and or record, which recording, or make a copy or save the process of how you do the visualization, or derive some data sets. So these are new attributes which you based on what you already have in the data set. Again, so these, you're not including completely new data sets or arbitrarily creating new ones. Okay, and back to consume, you have discover. So this is probably the most common one. And usually you have the data set, what you need to do is find something, find the answer. And sometimes the question is very specific. Sometimes it's much less so, so just find something interesting. Okay, present is what, once you finish the discover, you want to show the results to someone else, that's present. And enjoy is a specific type of consume, in the sense, this is not for, say, business or serious purposes. It's not part of a job. And it's just something like your hobby you are interested in doing. Okay, and the middle part is the search. As I said, we have 4 very type of searches, very specifically, and these are the names. You have to use exact as they are. And so these are different, depends on whether you know where the target is. And so the location known or unknown. And the second one is whether you know what you're looking for. And for example, and if you want to find the car, the most expensive car, and you sort your visualization by the price, and then you know the most expensive car must be at one end, where the largest values will be either at the left or right, depends on how you sort. And in those cases, the location will be known. And if you didn't sort your validation, for example, you use a bar chart to show each bar is one car and the height of the car shows the price, then you don't know where the car is. And you really have to go through the entire bar chart to find out which one actually has the largest value or largest price. Okay, and for the target part, and in the previous example, if you want to find out which car is the most expensive one, then the target is usually unknown, and you need to find out what that car is. Okay, or sometimes if you're for a different type of task, For example, you want to find, okay, how much does a Porsche cost? And then you know what you're looking for, then you just have to find it in the visualization. And once you know the target, and you probably don't know exactly where it's going to be located in your price bar chart, and then the location unknown, and that gives you locate. And then you have the other combinations which give you the lookup, browse, and explore. Okay, and okay, next part is about identify the query. So in terms of what you're looking for, it could be identify, looking for specific items, data items, could be compare. So looking at two things to see what their differences, and summarize. So it's overall conclusion. Okay, and then next one is this part on the right hand side is the so-called target, is the things you're looking for. So you could look at the entire data level, or you could look at individual attributes. And then you also can have specific things only unique to certain dataset types. So for example, and you can look at the connections between the data items or the dots here. And this is only relevant in the network. And also you can look at, say, the shape or area. And this is only relevant to geospatial data. And the more common ones are these ones. And you might look at the entire data level. So that means including all the data. It's more like everything about the entire data set, overview related tasks. So am I looking at trends or outliers? So the features will be some patterns which are not trends and outliers, basically everything that is not trends or outliers. And also say here, and even for the outliers, what you're looking for is only just say maybe one or a few data points, but you really need to look at the entire data set to know which one is outlier. Because if I don't have and don't know where these black points are, and there's no one that can tell this point is an outlier or not. Only in the context of other points I can know this one is outlier and this one is not. Okay, and the next one is about attributes, if you remember. So we have, and one data type is called attributes, so we have items and attributes. And attributes can be, say, quantitative or nominal, which, sorry, categorical or nominal. That means it's, and you can't do a computation. You can only say same or different, or can be numbers. So when you look, you can look at one attribute. In this case, you look at distribution. So it's kind of similar to the trend. But here, you only look at the one attribute, whereas the trends look at the entire data set. So it could have many, many more attributes. Or you look at extreme values for a particular attribute. And the examples we talked about before, we're looking for the car with the highest price. So that's an example of you looking at one attribute, which is the price, and you look at the extremes. Here is the most expensive. Similarly, can do the cheapest car. Okay, and then you can also look at the many attributes, multiple attributes, or let's say, and these are about the relationships between these different attributes. And so it could be dependency. That means one attribute change, the other will also change. And the change in the second attribute is caused by the change in the first attribute. And that is not always the case. And so that's the difference between dependency and correlation. So correlation, and if you look, it can be quite similar. For example, we can say, let's say the black dots and the yellow line are positively correlated, or let's say, sorry, and the two attributes represented by these dots, one is the x-axis, the other one is y-axis, and they are positively correlated because as value of X increases, its Y value also increases. So that's correlation. And then that can be, this can be positive correlated or could be negatively correlated, where the line will go, say, from top left to bottom right. In the sense, when the values of one attribute increase, the other decreases. Okay, and it's easier to say or detect correlation, but you cannot say this is a dependency. So you cannot say X depends on Y or Y depends on X. And even their values change in the same direction or positively correlated. And it's much harder you have to get more information to say, okay, is actually the change of X actually causing the change of Y? And or the other way around, or could be there's a third variable called the Z. And because that changes, that causes both X and Y change. Okay, and the last one is similarity. And so you're looking at the distribution of two attributes, and then they might share similar shapes. So that's similarity. So these does not have to be, say, a straight line like this, correlated. So you might have a curved line or S-shaped line, and the other one have exactly the same S-shaped line. So they're not particularly correlated in any way, but they are very similar in terms of trend. Okay, and then so that's those two parts. So the last part is about how. So it says once you understand the data types and the task you want to do is to design the validation, and there's different ways, the idioms we said, and in terms of guiding you how to design the validation. That's how part is. So that will be what is the kind of rest of the lecture is about. Okay, the first thing in terms of the how is actually about the markers and channels. So this is kind of the most important concept in the visual encoding or in design the visualization. Okay, gonna cover what are they and their types and their effectiveness. Okay, and first we're gonna talk about this concept called the visual encoding, and sometimes will be also called visual mapping. And this idea would be just to map attributes to graphical elements, and that's a bit abstract. And for example, you can represent quantitative attributes like sales to the length, which is the height of the bars. So that is mapping an attribute, which is the amount of sales, to a graphical element, which is the height of the bar or the length of the bar. Okay, and for the categorical attributes, for example, the name of the product, you can map to X coordinates. Okay, and so essentially, so that's say for each, we said because this is categorical, we can't really do any computation, but you can still map that to the X coordinates in the say each product would have a different X coordinates, and whether that's to the big or small one doesn't really mean anything, just say are different. And so actually that gives you this. In this case, we are mapping the sales to the height of the bar, and then the product to the X coordinates only just shows these are three different three different products. And so this gives you a bar chart. Okay. And then you can do many different visual mapping. So you have this a quantitative attribute, you have the sales and product. And you can do different mapping. And you can say, I map the sales to Y coordinates. Okay, so instead of using sorry, it's still the same here. But instead of length, I'm using this type using y coordinates. So how high it is vertically. And then I map each product still into the x coordinates. So these are still three products. They have three different x coordinates. And only I change in terms of mapping that to length. In this case, I'm mapping to just y coordinates, which give you the point. Okay. And so this is showing exactly the same information. And then you can decide which one is better. And currently, I couldn't tell. And it really depends on the type of task and in terms from the y. And usually, if you don't know that type of task, you can't really decide which one is better. Okay, and so these are the visualization representing two attributes, and you can actually add more information. And for example, you can add in the type of the product. So it can either be furniture or IT, and this is mapped to the color of the dots, or you can map to the color of the bar. So that's mapping a third attribute, which is the product type or category, to a graphical element, which is the color of the nodes, or maybe color of the bar. In this particular case, we map to color of the nodes. Okay, and if you want, you can add even more attributes. For example, we can map something, for example, the amount of profit into the size of circle. So here we are adding a fourth attribute to the visualization. The attribute here is profit, and the graphical elements will be the size of the circle. Yeah. And so as you can see, you can potentially visualize more than one attribute at the same time. And the general guideline would be only visualize attributes that's relevant to the task. And anything that is not relevant, and you try to visualize or present them in the visualization, and only would distract the user. Because usually the number of attributes you can represent is limited. It's not unlimited. You can't say, I want to represent as many as attributes as you want. Sometimes, and you have too many relevant attributes, you have to choose which one to represent. But usually only represent ones, which is the relevant ones. Okay. So in your case, I guess, yeah, we'll see some examples later on, but usually you probably would not represent more than 10 attributes in one visualization. That becomes too difficult. Okay, so we talk about visual encoding or visual mapping, and here the graphical elements. And most of these graphical elements we use is what we're going to call channel. And there's also the other thing, which is called marks. So marks is what you use to represent individual data items in your collection. So here the marks are dots, and here the marks are the bar. So each dot represents one product, and each bar represents one product. And here, and actually we are using something called a circle now, which is different from dot. I'm going to talk more about that a little bit later. Okay, so as we said, the mark is used to represent each data item in your data collection. And depends, you can have simple marks, which are like a dot, but you can have more complex ones as well. So the most simple one will be point, which is 0D. So that means it has no dimension. That means you have a point so one point is one product or one item from a data collection, but this particular point itself has no size or shape. So, and as a result, you can't really color it because it has no size or you can't say how big it is. Again, it has no size. And practically, if you want to draw them and make them visible, it has to be certain size, at least minimal. But conceptually, this does not have size. Okay, and then have 1D mark, and which will be line. So it can be a straight line, can be curly lines. So because they are 1D marks, it really only has one dimension, which is the length. It does not have a second dimension, which is like the width of the line. That becomes a 2D dimension, and which you can have area. So 2D marks and can be simple ones, and like say, and maybe just one square, rectangle, or the circles we saw before. Like the circles, these ones we saw before. And so the difference between the circle and the dot is the circle one now have size. So you actually have a radius, whereas if it's a point, you don't. So that's the only difference. Visually, they are very similar. It's just like the points are a bit smaller. But conceptually, it should not have any size for the point. Okay, and you can also have 3D marks. And for example, you can have a 3D cube or sphere to represent each data items. That's possible. But it's very rare. And it actually turns out to be not very effective, which we'll discuss or explain why that's the case later. Okay, and then the channels, we said the mark, each mark represents an item from your data collection. Then channels represents the attributes of your items, like the price, the quantity, the sales, the profit, the category, etc. Okay, and so it's independent of the marks dimensionality, and not always. For example, and you can always have, say, a channel, which is the XY positions of your mark, and this one would be independent of the dimensionality. But sometimes, for example, and you want to have the size of the mark, but then that means you at least has to be 1D. Then you can have length of line, or 2D. You have the size of the circle, and for 0D, like a point, you can't have a size channel. Okay, and there's some examples of different channels which you can use to represent the attributes. Obviously, the first one will be position. You can use X coordinates or horizontal position to represent one attribute. The vertical one as another, and you can use both at the same time. Obviously, you can do 3D as well. But in terms of visualization, you're probably limited to 3D because you can't really draw 4D. You can use color. And so usually you can say for each different product type or product category, I have a different color. And you can use shape as well. So each shape represents, again, I don't know, maybe say a different region. Okay, you can use how much a line is tilted to represent certain attributes. And obviously, you can use size to represent some numerical values as price, or profit, or weight, or quantity, etc., etc. And in terms of size, you can have 1D size, which is the length of a line, or 2D sizes, which is the area. And then finally, and 3D sizes, which is the volume. So how big or how much space each cube takes. Okay, and now we're gonna do some exercise, just to see if we can identify the markers and channels used in these relatively simple visualizations. And the one you're actually going to create will be probably more expensive and more complex than this. So we just want to say, okay, what are the markers and what are the channels used? And then obviously markers is always mapped to one data item. But for the channels, which attributes that channel represents? Okay, so I would recommend you to unmute, or if you can't, you can type in the chat as well. And so for the first question here, for this bar chart here, the question would be, what is the mark? Anyone? And you can type as well. So in terms of the question, oops, you have, these are different channels. Then we have some, say, examples of different marks here. Can be a point, can be a line, can be an area or shape, or could be 3D ones. But 3D ones are rare. And these are different examples of channels. Anyone? This first one? Yeah. Okay. And someone says markers are bars. Obviously, each of these represent a product, which is the items in your data collection. So marks has to be this. And someone say bars, and someone says lines. Okay. And in this particular case, we'll say it's line. And only because we're not treating this as a shape. We're not using the width of the bar to represent anything, just as say, this is a dot, not a circle, because we're not using the size to represent anything. So we'll call this a line. So bar is close enough. Okay. And the next one would be, what are the channels used and which attributes does each channel represent? So again, so these are the possible ones. You can do position is a channel, color is a channel, shape is a channel, or size is a channel. And they can use to represent attributes. And then what attributes is that used to represent? Okay, again, anyone?
Shape.
So the channel, say, is shape. And then which attributes, so let's say channel is the shape, and which attributes does that represent?
The product name.
Okay, so someone says, and we use shape to represent product name. Okay. Yeah. Okay. We also have people typing in the chat. It says channel are lengths of the bar. That it says basically how tall the bar is. Okay. And what does the length of the bar represent?
Sales.
Sales. Yeah. So that is the attribute. And this length of the bar is the channel. Okay. So that's, as we said in the previous slides. So length is one of the channels, the visual attributes you can see. So I would say that's a good one. And also people say position for product name. Okay, so that means on the x-axis or x positions, the different positions means different product. Okay, the attributes it mapped to is product name. Okay. So that's the channel, the vertical position or Y position. It represents sales, which is quantitative. And then the horizontal position, it represents product name, that's the attribute. And this is the categorical attributes. Okay, I think we are getting there. Now let's try again, this one. The second picture. What is the mark?
Point.
Point, yeah. Okay, and someone say dot. Okay, I think you get it now. So essentially, what you represent each product here is one of these little things. And so maybe the more, how do I say, we usually would call it point and just make it consistent, because when if we go back again, here you can see we call this 0D dimension mark points. And obviously, I think dot means the same thing, just to make it consistent. We'll still call it point. Okay, so then the next question would be, what are the channels and which attributes do they represent?
I
Anyone?
would say area. Area.
Area.
Channel is area. Yeah.
And what attributes does area represent?
Product name.
Area represents product name. Okay, but the same. When you say if we say the area represents the area of the mark represents product name, so I should be able to tell and which product is by looking at the channel. So we said that this is a point. So I mean, actually, it does not really have a size. So the area does not change, and even the area changes. We can't really tell which. I mean, it is not what we're doing here. Okay, and someone says the channel is the position of the point, and then the position usually you can have one or two positions. Again, let me go back a tiny bit. And so you can horizontal or vertical or both. So which case this is?
Both.
Both. Okay. And then what attributes does the position represent? So we have both the X position and Y position. So what attributes does the X position represent?
Sales.
Represent product.
X position.
Name. It's product name.
So you can see on the X-axis we said product name. So that means
product, and the Y position represents the sales, the rate of sales.
yeah, that's right. So we can see from the picture, say it says the X position is product name. So just say different position means different product. It does not exactly tell you what the name is. You could say, for example, add a label there. And then the Y position would represent the sales, which is very similar to the one before. So that tells you for this product, there's this much sales, this one has more, and this one has much less sales. Okay, so these are the two. Okay, and let's now move on to the third one. Again, the first part is say, what are the marks, or what is a mark?
Point.
This is a dot.
Okay, dot and point. Yeah, always do say point, and in the sense, and we not really using the size, so we don't use the size of the mark to do anything yet. So it's point. Okay, and what about the channels and the attributes they represent? What channels are used and which attributes they represent?
I think the channel is a color.
Color, yeah.
Yeah.
And what attributes does it represent?
The product name.
Sorry, the product?
The product name.
Product name. Okay, so someone
Category.
says,
Product category.
yes. So certainly we're using color channel to represent some attributes. We have different colors here, and red and blue. But what they represent is either furniture or IT products. So that's more like a product type or product category. And so that's why we're using the color to represent an attribute called product category, let's say.
I think in this case, the product name IT is the low sale.
Okay. So we have product name here, which meant it's actually represented by the X-axis. So this one is probably not product name again, because that's already used here. Okay, is there any other dimensions? Sorry, any other channels used and which attributes they represent?
Color.
Yeah, besides color, is there anything else? We already talked about color, and it represents the product type or category.
Also, position of the points is another channel used, just like in the previous graph.
Yeah, exactly. So we're still using the X and Y positions to represent product name and sales, which is exactly the same as before. So these didn't change. Here, we just added one more channel, which is the color of the point, and use that to represent a third attribute, which is the type of the product, either furniture or tea. Okay, let's do the last one. So you probably should know by now. Again, so first, and what is the mark? Anyone? Okay.
Circle and point both, because there
Okay.
are two circles and one is a point.
Okay. So first, you can't have both, and so you can only pick one, either circle or point or line.
Then
You can't be
circle.
both. Yeah.
Circle.
Yeah. And in this case, and because the size of the, how do I say, the dot actually represents something. So we say the mark is a circle, or in more general, it's an area. Area just means any 2D shapes, or any 2D marks. Okay.
Represent the sales.
Sorry?
This big one represents the most sales.
Okay, yeah. So that comes to,
Yeah.
kind of lead to my next question is what attributes the different channels represent. Okay, and so first, and to remember, say, and compared to this one, we still have the X and Y and color. These three channels are still there, and they still represent exactly the same thing. So those three will be still there. And the only thing we have, and compared to last one, that's different, and is now we also changing the size of these dots, which now is the size of the circles, or to represent something else.
I think the size of the dots represents the size of the product, not the rate of sales.
Yeah, I think so.
Okay, so anyone else? What does the size here represent? Which attributes does it represent?
Well, I think sales by category.
Okay, yeah. And so, I mean, that's a kind of like a trick question. So here, this visualization does not tell us what the size means. Okay, so it could be many different attributes, and probably is a quantitative one, like some numbers, but there's no way we can know whether they say it's sales, it's profit, or it's quantity, or anything. It could be anything. It's just not shown in the visualization. So that's also something you need to make it and be careful when you create your own visualization. For example, if you use any dimensions to represent something, you have to make it clear what it represents. So you have the, say, product name and sales on the X and Y axis. Then people know, okay, X position is product name, Y is sales. And you put in different color. You have the legend here says red means furniture and blue means IT. Okay, and then also that makes sense. People know what the color represents for, and what each different color means. And then similar for the size, and what you should include is a legend of different sizes as well, and indicating what it represents. Otherwise, there's no way the people looking at the visualization can know what it actually means. Yeah, okay, and so hopefully by now, you can understand at least what markers and channels are, and how we use them when we're creating the visualization. I mean, you probably do this anyway, so all of you know how to create a bar chart or scatter plot, but you're not thinking in terms of markers and channels when you do that. You don't think, okay, when I create the bar chart, the marker is a line and the channel is XY positions, for example. Okay, but this is a way you need to change the way you're thinking and when you creating the validation, and because then that way, and you will become more conscious in terms of the things you can control when you create the validation. So it's your decision to choose the mark and then choose which channel, and the second one is choose which attribute to show and how to show each attribute in terms of using channels. So that's really everything there is in terms of the validation. Usually the markers you choose will decide the type of the chart. And then sometimes this is also depends on the attributes you try to decide to include. And I guess, for example, for these two, the only difference is the marker you choose. And when you choose length or line, it becomes bar chart. And if you choose point, it becomes a scatter plot. And you can use other potential marks, for example, more complex 2D or even 3D shapes, which will give you slightly different type of chart. Okay, we're gonna talk a little bit more about the different types of channels. So if you remember again, so the channels is used to represent the attributes you want to show in the visualization. So some channels are better at represent categorical attributes. So it's like a product type or a product name. And these usually are the better ones for these, like his color or shape. And there's other channels which are better at represent numbers. And so these including the other ones, like the XY positions, the amount of tilt, or the length of line, the size of the area of the shape, etc. Or the volume of 3D shape. Yeah. So we have different types of channels. So just to repeat, so the color and shape is usually good for the categorical attributes, and the other ones are usually good for quantitative attributes. But again, this is a guideline or idiom, as we will say. And there's nothing to stop you to say, for example, using shape to represent numbers or quantitative attributes. It's just usually it doesn't work very well. And you can say, I use triangle to represent 1, star shape represent 2, curly line is 3, and L shape is 4. You could do that and use that in your validation. It just says people look at the validation will have a harder time to understand what is being represented. For example, it's quite difficult to compare, say, a triangle and a curved line, which one is bigger or smaller, or exactly what value that is, without actually referring back to the rules all the time, which made actually understanding the validation more difficult. Okay, and now that we come back to this effectiveness. So again, so this is an idiom. In the sense, these are based on the previous user and previous studies, experience, and research to say which channel is better at representing what type of attribute. Again, this is not absolute, but usually it's a good starting point. Okay, and again, so this is very important. The left and so this diagram again is very important. We're gonna probably need to come back to this in the next few lectures all the time. So what we have is on the left half is the different channels that can be used to represent quantitative values or quantitative attributes. Okay, and these are ordered from the most effective ones, which are the one on the top, to the least effective ones, which are at the bottom. Okay, and then this list is not exhaustive. There's other attributes you can potentially use to represent the quantitative values as well. For example, we didn't use, say, shape to include it here. Okay, in theory, you can still use shape, but it's just so bad, it's not even included on the list. Okay, and then so as we said, the top ones are the more effective ones, and the bottom ones are the less effective ones. So usually, you should always use the top ones, or start with the top ones. And as we said in the examples we've shown before, and you can represent, for example, 4 attributes in one validation. And for example, if all these 4 attributes, say among these, and say 3 of them are quantitative, and you probably want to use the top 3 attributes to represent the 3 quantitative attributes, the top 3 channels to represent the 3. Sorry, let me say it again. Use the top 3 channels to represent the 3 quantitative attributes that you need to visualize. And then don't say randomly pick 3 or start from the bottom. These are usually the ones should be avoided. Always start from the very top and going down the list. And so similarly, for the right-hand side, it's the different channels to represent categorical attributes. So these are the ones you can't do any computation on it, or even ordering. And again, the top ones are more effective, and the bottom ones are less effective. And so you have a much shorter list here. It doesn't mean you can use any of these channels to represent categorical attributes as well, but just they are not effective. They're not even listed here or compared here. Okay, and hope that makes sense. And then I'll maybe go through the list and roughly explain what these channels are, and before we discuss more. And so the first one says position on a common scale. And so this is the most common example would be the X and Y coordinates. So these are using the position. And more importantly, all these positions have the same start point. So for the different X values, they always have the same 0 position where they start from, to make it much easier to compare. Okay, and the second one will be the position on the unaligned scales. So you're still using the position, could be X or Y, but their start point is not always the same. So for example, for this value, it starts from 0 is here, and for this value, it's 0 is here. Okay, and this happens, for example, sometimes like the error bars you have in your bar chart, you might have an error bar on your, and it does not have exactly the same starting position. And this is less effective than this one. You probably can imagine, because the start point is not the same, but still quite effective. And the next one is length. So that's a 1D line, the length of the line. Next one is tilt. Okay, so this is much less often. People don't really use this, but it's still quite effective. And you can use size as well as a 2D one, or 3D positions. So this is saying how far away the point is from you. So if you display the data on the screen, and you can use the X and Y positions as along the surface of the display, and then the depth of the third dimension is usually how far away the point is from the people looking at it, because the display itself, and usually it's not 3D, like the monitors we look at is not 3D, it's really 2D. So you can only simulate the effect of 3D. And even you have a real 3D display, it's still less effective compared to the size, which is less effective compared to a length. Ooh. Okay, and the next one is about using color. and either using the color luminance and just treat it as the scales, the gray scales of the color. So from the complete white to complete black and the levels in between. And all the saturations of color, say this is from very red and to very little red, almost white, and different steps in between. So these two, it says roughly the same effectiveness, which is not surprising given, say, you can just treat this as, say, the different saturation levels of black. So you have less saturated black, which is basically give you the gray. Okay, and the last two, and the one is called curvature, and in terms of how curved the line is. And the last one says the volume. So you have a 3D shape, and depends on the size of the 3D shape to represent a number or quantitative value. And so again, finally, those two, the last two, is about the same effectiveness and probably the worst among everything on the list. And so I would say usually you should avoid the bottom half, start from the 3D position. You should avoid the bottom 5 and maybe try to use only the top 5. And I mean, it's very rarely that you will need, represent that many attributes and invariation anyway. Okay, and so now let's look at the right-hand side. As we said, these are different channels visually that you can use to represent categorical attributes. So like a product type, okay? And the first one is spatial region. So this picture is slightly misleading. What it meant is you can put all the product of the same type of the same category in one area, and the second type or second category in a second area, and so on and so forth. So that will be the most effective way to represent categorical attributes. Okay, and the next most effective option will be using color. So you can use different color to represent categories. So yellow is category 1, red is category 2, green is category 3, and blue is 4, so on and so forth. Okay, and then you can also use motion to represent. So that means you can't really do this in a static display or visualization, and you have to do it dynamically. So that means, for example, all the points that's moving is category 1, and all the points that's not moving is category 2. That's possible, less effective, and you can maybe even have different types of moving. For example, one is not moving, one is moving clockwise, and the other one is moving counterclockwise. So you can imagine, so it becomes harder and harder if you have more categories to represent. Okay, and then finally, you can use shape to represent different categories, and you can use different. So basically, each shape represents one category, and the cross is category 1, circle is category 2, square is category 3, and so on and so forth. Okay, so just to kind of quickly recap, and we have two lists, one for quantitative attributes and one for categorical attributes. And then they are ordered from the most effective ones to the least effective ones. And if it's not on the list, you probably should not even consider. And then when you choosing your attributes, sorry, you're choosing the channels for your attributes, you should always start from the very top. Okay, and then sometimes there is a conflict between the two. And for example, you can see the most effective ones is for quantitative attributes, is point position on common scale. So basically XY coordinates. So that's using the position of the data item, so the marks of the data item. And then similarly here, And if you want to choose the most effective channel for categorical attributes is the spatial regions. Again, it relies on the position of the items. So actually you can't do both at the same time. And so for example, if you use this one, position to show, say, the price of the product, and then you can't use position again because that's already showing the price of the product to show the type. So there's a conflict. And that's a design decision you have to choose. Should I use the position to show the type, or should I use the position to show the price? And then it comes down to which one is more important to show. So maybe in your particularly an analysis task and the type is more important for answering a specific task, then you probably want to choose to use the position to show the type and use other attributes to show the price, for example, length, because once you use this, you can't use the second one either. Okay, I'm going to come back to that later, but essentially that's the most important thing. And so this is probably the most important slide of the first 12 weeks. Okay, and so we already kind of covered the effectiveness, and we always said you always use the most effective channel, so the one on the top of either left or right hand side, and you use them to encode the most important attributes. So that's a design decision. You have to say which attributes is most important for the data type and analysis task, and then decide whether it's quantitative or categorical, and then use the highest ranked channels to do that. Okay, and then you have you've done that for the first attribute, and then you do the same for the second attribute, and you decide is it categorical or quantitative attributes, and what are the next available highest ranked channels. So for example, maybe the first most important one is price. Okay, so that's chosen. I'm going to use this to represent price. And the next one is, let's say, the profit. Okay, and so the next available highest ranked channel in this case will still be this. And because, say, I'm going to using the X coordinates for the price, then I can use the Y coordinates for the profit. And so on. Maybe the third one, most important one, is the product the type. Then I have to look at this part. Product type is categorical attributes. You already used the position. So the next most effective channel will then become color. Yeah, so then choose color. Okay, so the expressiveness essentially just says you need to match the channel with the type of attributes. So if it's a categorical attributes, you should be looking for something on this side. If it's a quantitative one, you should be looking for something on this side. I think that's straightforward. Okay, and then next we're going to talk a little bit about, say, how do we come up with this ranking, and show you some of the reasons behind. So why, say, the position is better than the length and better than the area and better than the color, and similarly for here. So there are a few different criteria, and the first one is accuracy. And the accuracy means so if people look at the channel, either say size, color, or position, how accurate people can estimate the actual value is. And then there's discriminability and separability. Okay, discriminability represents how many different values you can possibly represent. We'll cover this in more details in the next few slides. But for example, you can imagine we can use color to represent different types. But there's only so many of colors we can use before it becomes difficult to tell the difference between the two. Obviously, if you only have 4 colors, that's completely fine. But if you have 100 different colors, yeah, 100 say product categories, and each one is a color, then the difference between say any 2 categories, the color-wise, will be quite similar. Might be difficult to tell the difference. So that's discriminability. And separability means usually you have more than 1 attribute represented. That means you're using more than 1 channels. Sometimes these channels will interfere each other. So let's say one example, say you use the circle size to represent the profit and the circle color to represent product type. But you can imagine when the circle becomes really small and it becomes harder to see the color. So that means these two are interfering, and these two, and which is something you have to take into consideration when you design the gradation. And finally, the pop-up effect, and which is related to certain things we can, as human, can see very quickly. We'll see some examples later. Okay. Okay, we're going to start with the first one, which is accuracy. Going to talk about a little bit about accuracy, and is just how close we as human visually can judge the value is, and how well that matches to the real value it represents. And it turns out, for different channels, and the levels of accuracy is quite different. Okay, and this is actually what people found. So on the x-axis, it shows the physical intensity. And so it could be, say, this one says brightness. So how bright the color is, or how, and this one says steps. So that's how far away you are from the person. The area means how big, and the circle or the square is. That's the length. And this is the saturation of the color. So how colorful that is. Sorry, how much color that is. Is that just a tiny bit red or very, very red? And this is electric shock. Okay, so this is just included here for fun. But it says if you give people an electric shock and how much perceived sensation that is. So that's people with the rate, for example, and for brightness. And when you increase double the brightness, increase from 1 to 2, and people's perceived increase is, say, only from 1 is maybe here, let's say like 0.7 something, to here, which is only slightly higher than 1. That means about maybe say 1.1 or 1.2. So that means when the physical intensity doubled, the perceived change or perceived sensation only changes a little bit, not doubled. So in that sense, this is not accurate. So what is actually measured is roughly, say, the perceived sensation is only about the half of the actual changes. So let's say you use brightness to represent, say, the profit of the product. When a product is twice as profitable, but when you see visually, you will think maybe the difference is only 50%. Okay, so I hope that makes sense. And these two lines, and very close, that means they almost have similar kind of change. So here, the difference is about 3/4 of. So that means if the difference is doubled, and what you perceived is about maybe 2/3 of the, not 3/4, 2/3 of the change. So if it's doubled, you think that the change is about maybe 60, 70%. And then we have this purple line, and which actually shows, okay, and the perceived changes matches very well with the actual physical change. That means if the lens doubled, and what people see and think is the value doubled. Okay, so that's much more accurate compared to these ones. That's one. Lens is a more effective channels compared to area and depth. So that's what we're seeing here. So you can see the lens is a better one compared to the area or the colors or brightness. Yeah. Okay. And so these are the ones on the other side of the lens. So these ones, which I would call, people would underestimate the changes, whereas these ones, people tend to overestimate the changes. And so it says saturation is 1.7. So what means is if the actual change is doubled, and what people think is actually maybe more than doubled, 1.7 times the change. And then the electroshock is the most sensitive ones. Even you just increasing the voltage and by a tiny bit, people think it's hurt way more than the increase. Maybe you only increase the voltage by 10%, and people might feel the pain like a doubled or 3 times. That's a very high line. And then for the visualization purpose or representing data purpose, closer to the diagonal is better. And because then the perceived changes matches well with the actual changes in the value of the data. Okay, we're gonna do some tests now just to see if it actually is accurate. And so I'm gonna do a poll. So the first one, I'm using the saturation. So how blue these two circles are. And then you need to choose between. So is the second one 1.5 times bluer than the first square, or is twice, or is that 2.5 times? Yeah. And I'm gonna do the poll so you can choose. Maybe I should have one. Give me a second. Yeah, just this one. Yeah. Cool. And now I'm gonna get the slides back. I don't know why it disappeared. So it's now your question. So choose, is it the second one is 1.5, 2, or 2.5? Okay, I have 9 people voted so far. I'm gonna wait to give you maybe 30 more seconds so you can decide. Okay, 10 more seconds. I know some people probably can't vote because they are using on the phone or tablet, that's fine. Okay, I'm gonna stop there now. Okay. So you should be able to see the results now. So 20% picked A, 1.5, and 36% picked the B, which is 1.5. Sorry, which is twice, and 43% picked the last one, which is 2.5 times. And the correct answer, oops, why it's got all black now. The correct answer is actually 2. So the second one is actually twice as blue. So this is something you can set just in the, when I create a circle. And if we look back on the previous slides, you can see for the color saturation, people actually tend to overestimate, which is matches very well. I think more people think that's 2.5 times bluer than this. Okay, so that worked well, or worked as expected. I'm gonna do the next one. Okay, this time, how do I redo this?
Aline, Amanda foi trabalhar esses dias? Pois olha, não falou nada da Ieda. A Ieda foi para o hospital com a pressão alta.
Okay, and I'm gonna do next one. Don't vote yet. Why people is already voting? I haven't shown you the question yet. Why it's got black again? Okay, sorry, my apologies. It goes black again for some reason. Okay, and so this is the second question. And this time I'm using the lens to represent a value, a number again. And it's still the same 3 choices. One is 1.5 times and twice, or 2.5 times. So the second one compared to the first one is at 1.5 times longer, twice longer, or 2.5 times longer. Okay, I'm gonna reset the poll. Okay, so now you can vote. So the second line is it 2.5 times longer, 2 times longer, or 1.5 times longer compared to the first one. Okay, wow. Okay, 10 more seconds and we'll finish. Okay, wow, that's quite surprising. I'm gonna end the poll there now. You can see the results. So 20% picked 1.5 times, 15% picked it twice, and 2.5%, sorry, then 65% choose 2.5. So that's the most popular one. And the answer actually should be also, should be twice. Sorry. Why is happening again? No. Okay, so this is a bit surprising, and because the lens is this one in the middle based on their experiment results, they think it should be matched. So in the actual experiment, and the second one is exactly twice the length of the first one. So it's a bit surprising, saying actually very few people actually picked the second one. Okay, I'm going to do one last experiment. This time using the area and then we have two circles, and just to say how big is the circle in terms of area compared to the first one. Is that 1.5 times bigger, or twice the size, or 2.5 times the size? Yeah. I'm gonna. Okay, and so can you vote now? I relaunch the poll. If you think, and the second square is 1.5 times the area, or 2 times the area, or 2.5 times the area of the first square, the one on the right, is how many times bigger than the first one? Okay, 10 more seconds and we'll stop. Yeah, okay, and we'll stop there now. And you can see the results. So 35% picked 1.5 times, and about 60% picked 2 times, and only 6% picked the 2.5 times. And the correct answer again is still twice. And so if we look at here, based on this and the area, people tend to underestimate. There's only 0.7, but actually majority of people actually get it correct because it's twice. Still, I mean, much less people overestimated compared to the people underestimated. Okay. Okay, and so hopefully that gives you some idea, and in terms of how the visual perception can differ from the actual value changes. Okay, we kind of running out of time. We only have 5 minutes left. So I maybe just cover one more slide and then we'll finish the rest in the next lecture. Okay, and then just go back here. If you remember, we had 4 different criteria to evaluate which channel is most effective. So we look at the accuracy. Now we're going to have a look at the discriminability. Okay, so discriminability is to say how many different values it can represent before it becomes too difficult to tell the difference between the values. Yeah, and some channels has very limited number of distinguishable values. Okay, for example, here we are using line width, and so this is a visualization. So what it shows is it shows the trade between different EU countries or European countries. And so you can see, each country is a circle, and the size of circle also represents the total trade. So that you have legends, and you know the size channel represents the total trade from a country, and it tells you exactly, say, the biggest circle represents 5,000, I think maybe 5,000 million, so that's 5 trillion or something. And then there's lines connecting these different countries, which means the amount of countries that's being traded between the amount of trade between countries. And so there's UK, and D is Germany, and there's a fairly thick line. So there's lots of trade between these 2 countries. And there's UK and between Ireland, even in total Ireland, because Ireland seems to be only trade with UK, and there's lots of trade in between, and so on and so forth. And so this is a second attribute, which is the amount of trade between 2 countries That's represented by the line width. So the thicker the line, the more trade between the two countries. Okay, and the main point here is, say, it's easier to see, for example, this line between Ireland and the UK is thicker than this line between UK and Norway. That's fine. And then, but then how many different levels you can represent with the line width is very limited. If you look at these symbol here, and these 3 steps is okay. So that's 500, that's 250, and 100. But you can imagine if you need to represent any more than this. So if you represent 100, 150, and 200, so by adding 2 more levels between 100 and 250, the difference in the line width will be very small, and in most cases, the human will not be able to see. So that means a poor discriminability. Okay, and so that might not be a problem. And if you only want to represent 3 values between 100 and 500, that's completely fine. And then, but if in some cases you want to represent 5 or even 10 different values between these 100 and 500, then this is not a good channels to do that, because the channels, the discriminability does not support the number of values you need to show. Yeah. Okay, and there's only so thick the line you can be. I mean, this is probably the thickest you can do. You can't do any thicker than a line than that. Otherwise, it becomes more like a, say, rectangle or even a square, which does not make much sense on visualization. Okay, so that's when you want to consider in terms of discriminability. Okay, I think we'll stop there then. So yeah, and we will